Welcome to AI Frontiers. Today we spotlight breakthroughs in AI reasoning, formal verification, and multi-agent systems, highlighting 6 new cs.AI research papers published on September 7, 2025. Learn how these advances are shaping tomorrow's technology with a special focus on the Proof to Silicon project. Whether you're a researcher, developer, or AI enthusiast, this episode will guide you through the future of AI innovation. A major leap in AI reliability has arrived. As of 2025, nearly 72% of natural language hardware requests can now be transformed into verified, synthesizable silicon. Imagine describing your next device in plain English and having AI not only design it, but also mathematically prove its correctness. This level of intelligence is beginning to reach across all digital domains, blurring the line between human intent and machine execution. Today, we investigate how these advances are reshaping our world. Why do these new AI advances matter? Artificial intelligence is fundamentally changing the ways we reason, verify, and collaborate. The 6 papers featured today address efficiency, trust, and creativity, advancing state-of-the-art methods from hardware design to storytelling. Our aim is to clarify these breakthroughs and their broader impact, equipping you to engage with and contribute to the evolving AI conversation. Let's set the context. cs.AI is often described as the brain factory of computer science. Imagine a city where AI is the district in which machines learn, reason, and create. Here, systems not only execute algorithms, but also detect patterns, invent strategies, and solve complex problems. The stakes are high, offering smarter automation, deeper insights, and safer systems. However, as AI's complexity grows, challenges such as trust, reliability, and interpretability become ever more critical. A central research theme is efficient reasoning in large language models, or LLMs. Recent work by Wang and colleagues demonstrates that LLMs can trim their own reasoning chains for clarity, while Zhao and colleagues show that reinforcement learning can improve reasoning quality. Think of these advances as akin to a skilled detective who focuses only on the crucial clues, delivering clear, concise, and convincing explanations rather than rambling through unnecessary details. The goal is to make AI answers both understandable and reliable. Reinforcement learning, or RL, is transforming how AI models are optimized. RL guides models toward better answers and more reliable behaviors by providing feedback, much like training a pet with rewards and corrections. Jia and colleagues employ RL not to retrain entire models, but to repair prompts, ensuring hardware correctness. This approach optimizes both code generation and the reasoning process, expanding AI's adaptability and reliability across diverse tasks. Another prominent theme is the rise of multi-agent systems and creative reasoning. Li and colleagues introduce Pillager Bench, enabling agent competition and collaboration in Minecraft, while Xiao and colleagues present the reverse-engineered reasoning, REER, framework for creative generation. In these systems, AI agents invent new strategies by competing and collaborating, much like players in a team sport. Backward reasoning techniques are used to uncover the hidden steps that lead to innovative solutions. Let's turn to key findings through mini stories from the research. Jia and colleagues achieved the transformation of 72% of hardware specs into verified, synthesizable designs. Wang and colleagues' edit method enables LLMs to generate concise yet accurate answers. Jia and colleagues' dynamic reasoning efficiency reward, or DRER, shapes AI models into more confident and efficient reasoners. Xiao and colleagues leverage REER to help AI systems learn to innovate by analyzing outcomes, while Li and colleagues position Pillager Bench as a competitive arena reminiscent of the Olympics for multi-agent AI. Focusing now on the paper of the day, Proof to Silicon by Jha and colleagues addresses a long-standing hurdle. AI-generated hardware often fails formal verification. The central question explored is whether correctness can be guaranteed by design. Proof to Silicon applies reinforcement learning to optimize prompts, not the underlying models, effectively bridging the gap between human intent and machine execution. This work emphasizes reliability, automation, and mathematically provable results. How does Proof to Silicon operate? The process begins with a plain English hardware specification as input. Reinforcement learning is used to iteratively refine prompts for large language models. The models then generate code in Daphne, a language tailored for formal proofs, which is subsequently checked by automated verifiers. Verified code is translated to C and synthesized into registered transfer level (RTL) hardware. The RL agent continuously learns from both successes and failures, incrementally improving prompt quality. Proof to Silicon's results mark a new era in AI-driven verified design. Formal verification rates increased by up to 21%, and nearly 3/4 of specifications yield hardware that is both provable and usable. Notably, there is no need to retrain the underlying language model. This approach sets a precedent for correctness by construction, with potential applications extending to software, policy, and other safety-critical domains. Looking ahead, envision AI as a rocket with formal verification serving as its guidance system. The principle of correctness by construction could soon extend to all forms of digital creation. Ongoing advances in reinforcement learning and prompt engineering continue to open new research frontiers, spanning software, communication protocols, and creative content. The future points toward AI partners that are simultaneously creative and consistently reliable. To conclude, efficient reasoning, formal verification, and collaboration are advancing at an unprecedented pace. Seminal papers by Jha, Wang, Li, and others are expanding the AI frontier. However, significant challenges remain, including model generalization, interpretability, and the collection of high-quality creative data. Your questions and insights will help shape the next generation of AI. Engage with these papers, share your perspectives, and continue to question the future potential of artificial intelligence. This episode's deck was synthesized using GPT 4.1 by OpenAI for text structuring and summarization, with TTS synthesis provided by OpenAI and image generation via Google Tools. Content accuracy was reviewed by a human expert, though some oversights may remain. Listeners are encouraged to consult the referenced papers for complete details. All references are included for further study. Stay connected with AI Frontiers by subscribing for the latest in AI research and innovation. This channel brings together a community of researchers, developers, and curious minds dedicated to exploring the AI frontier. Share your thoughts and questions to help advance the conversation. Thank you for joining us as we explore the latest AI breakthroughs. In this podcast, we bring you the latest breakthroughs in computer science and AI. Straight from the archive preprint server, from neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.